Hey guys, tonight we're heading to the far reaches of the solar system, out past Saturn's grand rings, beyond Uranus's sideways tilt, to a pale blue dot that looks serene, until you take a closer look, Neptune. From here, the sun is just a bright star, and the wind howls at supersonic speeds. But the real mystery isn't Neptune itself. It's what's dancing around it. Moons that orbit the wrong way. Moons that dodge each other with impossible precision. And a moon that may have knocked out the rest of the family in a dramatic cosmic coup. You probably can't fathom this, but some of Neptune's moons move in ways that literally break our math models. They don't follow the rules. They don't line up like they're supposed to. It's like showing up to a family reunion and finding out nobody's related, and half the guests are circling the buffet backwards. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're listening from and what time it is where you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You arrive at Neptune slowly. There's no rush. It's 2.7 billion miles from Earth after all. As you glide closer, the blue hue deepens, tinged with icy whites and fleeting shadows. It looks calm, like a frozen ocean. But beneath that smooth exterior, things get rowdy. Neptune is the 8th and farthest official planet from the Sun. It's cold, colder than any place you've ever imagined, even on the worst winter morning. Temperatures can dip to minus 373 degrees Fahrenheit, which is just 1 degree above absolute zero, where atoms stop vibrating. So yes, even your frostiest childhood snowball fight doesn't quite compare. You pass through the outer halo of faint rings, which flicker in and out of view. They're nothing like Saturn's clean edges. Neptune's rings are threadbare and clumpy, like someone tried to tidy up space dust with a broken vacuum. But tonight, you're not here for the rings. You're here for the moons. Neptune has 14 known moons, each more baffling than the last. Some are small enough to fit comfortably in a city block. Others are vast and mysterious, like Triton, Neptune's biggest moon, and the star of tonight's bedtime drama. The first thing you notice is the orbits. They don't behave. Moons normally orbit in smooth, predictable ellipses around their planets, counterclockwise, following the natural momentum from their birth in the planetary disk. But not here. Triton, the big one, orbits backwards, retrograde. That's like being the only car on the freeway going the wrong direction and somehow not causing a pileup. And that's just the start. You've got Naiad and Thalassa, 2 tiny moons with names that sound like they belong in a Greek poetry slam, performing orbital acrobatics that defy gravity's script. There's Nereid, a moon with an orbit so stretched out it looks more like a comet's than a moon's. And there's Proteus, a potato-shaped chunk that somehow stayed out of trouble, at least on the surface. Astronomers believe Neptune didn't always look this way. Its moon system may have once been as orderly as Jupiter's, until something, or someone, arrived and wrecked the whole setup. That someone was probably Triton, but we'll get to that little interloper soon. Right now, as you coast over Neptune's dayside, You notice storm systems drifting across its upper atmosphere. They look like marble streaks, spinning silently in the blue gloom. Neptune holds the record for the fastest winds in the solar system, over 1,300 miles per hour, faster than the speed of sound. Not that you'd hear them. Sound doesn't travel well out here. Below you, the planet itself isn't solid. It's a swirling sphere of hydrogen, helium, and methane. Yes, that same methane that gives it its blue colour, and, if you're feeling immature, inspires a few jokes about cosmic flatulence. There's a calmness to Neptune, but it's the kind of calm that feels ominous, like a quiet theatre before the curtain rises. You get the sense that this place isn't as peaceful as it looks, and you'd be right, because while Neptune spins with elegant poise, its moons are in chaos. Some are missing, some are probably fragments of others, some refuse to sit still for long enough to get a decent photo. Voyager 2 only got a brief glimpse in 1989, and since then, we've mostly been squinting at distant pixels and guessing. But even those guesses tell us something strange happened here. As you drift into Neptune's shadow, where starlight replaces sunlight, you feel the vastness settle in. The stars don't twinkle out here. They shine with a steady, frozen intensity. And among them, the moons begin to emerge like ghosts around a haunted planet. Triton first, glowing pale against the dark, then Nereid, arcing along its absurd path. Naiad and Thalassa flitting past each other like caffeinated fireflies. You float here a moment longer, just watching. The silence of deep space is complete, and the moons continue their unruly dance, as if daring you to make sense of it all. You linger near Neptune's twilight, watching that icy blue orb spin slowly beneath you. It's easy to forget, floating in this serene cold, that Neptune almost wasn't here to begin with. It's not just that it's distant, it's that it defies the original layout of our solar system, like someone rearranged the furniture after the architect had already left the room. See, Neptune wasn't discovered by simply pointing a telescope at the sky and spotting a new blue dot. No, it was found through math. In the 1840s, astronomers noticed that Uranus, Neptune's next-door neighbour, was wobbling strangely, like it was being tugged by something invisible. So they did what any good scientist would do. They ran the numbers, guessed where the missing culprit should be, pointed a telescope there, and voila, Neptune. But even today, Neptune's very existence is something of a cosmic eyebrow raiser. Based on how planets supposedly formed, Neptune is too far out and too massive. In the early solar system, there shouldn't have been enough material in that distant zone to build something this big. It's like trying to make a wedding cake using only a handful of flour and a single egg. Some astronomers think Neptune started closer to the Sun and later migrated outward, slowly, methodically, like a very cold hiker backing away from an awkward conversation. This idea is part of something called the Nice Model. Yes, named after the city in France, not the adjective. And it suggests that the outer planets wandered around quite a bit before settling into their current spots. This planetary shuffle may have knocked countless smaller bodies around, like cosmic bowling pins. Moons, asteroids, comets. They all got caught in the gravitational crossfire. And Neptune? Well, it apparently picked up some strays along the way. You glance over your shoulder, Figuratively, of course, and imagine Neptune drifting outward millions of years ago. As it wandered, it may have entered regions packed with icy bodies, now part of what we call the Kuiper Belt. Think of it as the solar system's dusty attic, filled with leftover bits from planet making. And during this journey, Neptune may have snagged a few companions it wasn't supposed to have. One in particular stands out. You can't see her clearly yet, but she's there, pulling strings from the shadows. Triton. But we're not quite ready for Triton's dramatic entrance. For now, you float above Neptune's atmosphere, feeling the weight of the solar system's past, hanging thick in the silence. Despite its distance, Neptune has a huge impact on the architecture of the outer solar system. Its gravity helps sculpt the orbits of distant objects, and may even be hiding other celestial bodies in its wake, like the hypothetical planet 9. Astronomers still argue whether this phantom planet exists, or if Neptune is just good at flinging rocks into weird places. The farther out you go, the fuzzier the rules get. Planets aren't where they're supposed to be. Moons don't behave. Orbits bend and twist into mathematically awkward spirals. And Neptune is right at the heart of that confusion. Take its mass, for example. Neptune is only slightly smaller than Uranus, but denser. That means it's heavier for its size, a kind of cosmic overachiever. It also has a magnetic field tilted wildly off-axis, shooting out at a strange angle like a broken compass. And let's not forget the wind. It's still the fastest in the solar system. Imagine standing on a frigid ledge while 1,300 miles per hour winds scream past you. Except there's no air to hear, and you're probably frozen solid. So, not exactly a vacation destination. Still, there's something beautifully hypnotic about Neptune's slow spin and deep colour. The methane in its upper atmosphere absorbs red light and reflects blue, giving it that trademark icy glow. And as your view shifts to the night side, the stars begin to return. Dozens of them, shimmering against the darkness. But it's not the stars you notice, it's the motions. You begin to realise how much weird is happening in Neptune's orbit. Some moons follow tight, tidy circles, others wobble like drunken satellites, and some, like Nereid, just swing by every few months as if they forgot they were part of the system. That irregularity is a clue, one of many, that Neptune's current moons are not the ones it started with. Some astronomers believe Neptune may have had an original, more orderly family of moons, born with the planet, following the rules, taking their vitamins. But something big happened, something disruptive, something that rewrote the guest list entirely. One popular idea is that when Triton was captured, likely from the Kuiper Belt, it didn't just park itself in orbit. It bulldozed through the old system, ejecting or destroying Neptune's native moons in a kind of celestial takeover. Sort of like inviting a new roommate who then redecorates by throwing out all your stuff. Even today, Neptune's remaining moons appear mismatched. Some orbit close in, others are distant and erratic. They don't line up by size, orbit, or inclination. It's like Neptune's trying to pass off a collection of moon souvenirs as a proper family. You look back toward Neptune now, watching it spin slowly beneath you. It's easy to get lost in the swirl, in the hypnotic layers of blue and white and shadows. But you can't shake the feeling that this planet is still keeping secrets. The kind of secrets that don't show up in textbooks. The kind that you only glimpse when you sit still long enough to notice the patterns in the chaos. And tonight, you have nothing but time. As you drift farther from Neptune's upper clouds, something strange catches your eye. A faint shimmer, like a loose thread in a tightly woven curtain. You tilt your view, and there it is again. The glimmer of a moon too small to glow, but too bold to hide. Meet Naiad, Neptune's innermost known moon, and quite possibly the most anxious rock in the entire solar system. At just about 60 kilometers wide, Naiad is more dust bunny than moon, but she zips around Neptune with the energy of a squirrel on espresso, completing a full orbit in just 7 hours. She stays remarkably close to the planet's surface. In fact, she's so close that if Neptune had slightly puffier rings, she'd probably be brushing against them like an over-enthusiastic ceiling fan. But Naiad isn't just fast, she's weird. Her orbit is tilted and twisted in a way that suggests she's actively dodging another moon, Thalassa, the next one out. The two perform a sort of choreographed dance, never colliding, always sidestepping. Every time they pass, Naiad is either slightly above or below Thalassa's orbit, like two skaters weaving through each other on invisible paths. It's elegant, it's baffling, it's the kind of cosmic ballet that would make a choreographer cry. Astronomers call this motion a resonant dance, a term that sounds like it belongs in a Jane Austen space opera. Specifically, Naiad and Thalassa are locked in what's known as an inclination resonance. Every time Thalassa orbits Neptune once, Naiad orbits exactly twice, staying out of the way like a considerate roommate who tiptoes around your nap schedule. But here's where it gets juicy. This isn't the kind of motion you get from moons that form together. No, this behavior suggests that something disturbed their orbits long ago. And astronomers still argue whether it was Triton's arrival, a close pass from an ancient asteroid, or some other drama lost to time. You float just above Naiad now, watching her scuttle across Neptune's face. The moon is too small for detail, just a lump of rock and ice, pocked and scarred. No atmosphere, no chance of life, but plenty of personality. Thalassa, following her just outside, is a bit larger and more reserved. She takes about 7.5 hours to complete her orbit, a leisurely pace by Naiad standards. The two of them are like cosmic siblings on a long road trip, forever keeping just enough distance to avoid bickering. There's something oddly comforting about this repeated pattern. In a universe ruled by chaos and collision, these two found a rhythm, a system that works, even if it shouldn't. As you coast along with them, Neptune looms in the background, its blue surface whispering past like a gentle tide. And for a moment, you forget just how precarious all of this really is. These moons are fragile, their orbits delicate. A single rogue asteroid could ruin everything, and yet here they are, dancing in sync for billions of years. But let's not get too sentimental. This pair isn't alone. Other small moons pepper Neptune's orbit like leftover pebbles from a demolished garden wall. There's Despina, which orbits just outside Thalassa, and Galatea a bit farther out. All of them are irregular in shape, resembling space potatoes that got left in the freezer too long. Despina's claim to fame: It might be helping to shepherd Neptune's faint Leverrier ring, keeping it from falling apart with gentle gravitational nudges, sort of like a mole cop for ice particles. Not glamorous, but someone's got to do it. Meanwhile, Galatea may be responsible for corralling another ring segment, the Adam's ring, where a mysterious clump called Liberty resides. Yes, even the rings have names out here. Because of course they do. But back to Naiad and Thalassa. When NASA's Voyager 2 spacecraft passed by Neptune in 1989, it only got a fleeting glimpse of these moons. The photos were blurry, and their movements were impossible to track in real time. It wasn't until decades later, using data from the Hubble Space Telescope, that astronomers realized Naiad and Thalassa were engaged in this orbital dodgeball. And even now, with all our instruments and algorithms, we're still not entirely sure why. Some believe it's a long-term survival mechanism, each moon slowly adjusting to avoid the other. Others think it's temporary, a phase that will eventually end in either collision or ejection. A cosmic telenovela waiting for its finale. One thing's for sure, Neptune's inner moons are not relaxed. They spin fast, orbit low, and survive through precision and timing, not brute strength. They're the scrappy survivors of a system that's seen better days. As you trail behind Naiad's tiny wake, the sunlight begins to dim again. Neptune rotates on its axis every 16 hours, casting brief sunrises and sunsets over its moons. You catch the glow of Thalassa slipping behind the planet, vanishing into the dusk. And in this quiet moment, you realize something simple but profound. Motion is survival out here. Keep moving, keep adjusting, and maybe, just maybe, you'll stay in a dance a little longer. You're drifting outward now, easing past the inner edge of Neptune's moons and entering the domain of someone far more enigmatic. She appears slowly, a heavy shadow against the glimmer of distant stars. Not large in the grand scheme of things, but for a moon, especially one so far from the warmth of the sun, Triton is a queen. And not just any queen. Triton doesn't orbit Neptune like the others. While Naiad and her crew circle dutifully in the same direction that Neptune spins, Triton does things her own way. She orbits backwards, in what's known as a retrograde orbit. Imagine walking into a crowded escalator and climbing it the wrong way. It's bold. It's disruptive. It's Triton. And that's not the only red flag waving proudly in the Neptunian breeze. Triton is big, so big in fact, that she makes up more than 99% of the mass of all Neptune's moons combined. If you put every other moon Neptune has into a giant celestial blender, which sounds unnecessarily dramatic, you still wouldn't have half of Triton's mass. She's a gravitational heavyweight, crashing a party of dainty dancers. The leading theory? She's not from around here. Most astronomers agree that Triton was once a Kuiper Belt object, one of those icy distant bodies orbiting beyond Neptune like shy kids circling the edge of the dance floor. At some point, perhaps billions of years ago, Neptune wandered close enough to catch her. How exactly that happened is still a hot debate. Some suggest that Triton was part of a binary system, two icy objects orbiting each other like figure skaters mid-spin. Neptune's gravity may have pulled them apart, flinging one partner into deep space while capturing Triton for itself. It's like adopting a cat after it leaves a rival household during a thunderstorm. Triton didn't ask to be here, but now that she is, she's firmly in charge. And her arrival wasn't peaceful. When Triton was caught in Neptune's gravitational web, she would have started with a highly elliptical, chaotic orbit, one that intersected the paths of any pre-existing moons. Over time, tidal forces tugged and twisted her orbit into the tight retrograde loop we see today. But the cost? Any original moons orbiting Neptune in the same direction were likely destabilized, thrown out, smashed into each other, or absorbed into Neptune itself. In other words, Triton didn't just join Neptune's moon system, she replaced it. Even now, her orbit is slowly decaying, inch by cosmic inch. Tidal forces are gradually pulling her closer to Neptune, and someday, eons from now, she may either crash into the planet or be shredded into a spectacular ring system. Future astronomers, if they still exist, might watch that event the way we watch fireworks, only much, much colder. But for now, Triton endures, silent, cold, and deeply peculiar. As you drift toward her, you begin to see her surface. It's smooth, weirdly smooth. Most large moons in the solar system are cratered and battered, like space-worn shields. But Triton, she looks almost too clean. That's because she's active, not in a warm, Earth-like way. No birds, no rivers, but in a cryovolcanic way. Cryovolcanoes. Yes, you heard that right. Triton occasionally erupts with icy gases, spewing plumes of nitrogen gas and dark material high above its surface. Voyager 2 spotted these jets back in 1989, hundreds of kilometers tall, drifting sideways in the thin atmosphere like eerie ghost trails. You imagine standing on that surface. The temperature is around minus 235 degrees Celsius. The sky is black. The ground crunches beneath your boots. Frozen nitrogen, maybe. Or some cocktail of ices you'd never want in a drink. Then, out of nowhere, a geyser bursts in the distance, whispering gas into the void. It's not exactly a relaxing vacation, but it is breathtaking in its own frigid way. And then there's the cantaloupe terrain. That's not a joke, it's a real term. A huge portion of Triton's southern hemisphere looks like the skin of a cantaloupe melon, lumpy, pocked, and mysterious. Scientists aren't sure how it formed. It could be the result of internal convection, where Triton's icy interior slowly churns and bubbles up through the surface like a cold stew. Or maybe it's ancient terrain that was jostled and reshaped during a long-lost cataclysm. Either way, it's weird. And that makes it perfect for tonight's journey. Astronomers still argue whether Triton is geologically active now, or if Voyager just caught the tail end of some ancient outgassing party. But the moon's surprisingly thin atmosphere, made mostly of nitrogen, suggests there's still something happening beneath that crust. Something alive, in a mechanical sense. And here's a little twist. Triton has a retrograde, tilted, and oddly circular orbit. Normally, retrograde moons are also eccentric. They loop out in wobbly ellipses. But Triton's orbit is remarkably circular, implying that tidal forces have had a long time to shape her motion. So if you're imagining her being captured last Tuesday, think again. Triton's been haunting Neptune for a very long time. long enough to kill off other moons, smooth her orbit, and still send up geysers on occasion. She's not new. She's just mysterious. As you float silently above her, one last thought settles in. Triton doesn't belong here. She's a wanderer, an interloper, a cosmic misfit playing queen in a borrowed court. And yet, somehow, she fits. You leave Triton behind, watching her vanish slowly into Neptune's shadow, silent, distant, unknowable. But don't worry, she'll be back again in a few hours, circling in the wrong direction like a goth cousin at a family reunion. Your path now curves away from Neptune's main entourage, gliding into the outer neighbourhood, past the known, the named, and the slightly chaotic. Welcome to the land of Neptune's irregular moons, a collection of dim, scattered bodies that orbit far from the planet, where the sun is barely a distant whisper and gravity itself seems unsure of its job description. If the inner moons were dancers and Triton the diva, these outer moons are the spectators loitering in the lobby, disinterested, distant, and thoroughly odd. There are 14 known moons of Neptune, and 7 of them are these irregulars, found so far from the planet that their orbits barely count as belonging to Neptune at all. They're tiny, most of them under 100 kilometers across, and they all follow strange, elongated paths that loop around Neptune in lopsided ovals. You might meet someone like that in an indie coffee shop, elliptical, retrograde, hard to pin down. Let's begin with Neso, the most distant confirmed moon in the entire solar system. Seriously, no other planet has a moon as far out as Neso. If Earth had a moon like this, it would be hovering somewhere near the orbit of Mars. That's how far-flung she is. Her orbit is so enormous and slow that it takes over 26 years to make a single trip around Neptune. In that time, Triton would have completed over 1,000 orbits, probably rolled her eyes 999 times, and staged several passive-aggressive moon protests. But Neso isn't alone. She belongs to a curious little club, the far-out moons of Neptune, including Pisamathe, Sao, Laomedea, and Halimede. All of them are named after sea nymphs, which sounds poetic until you remember they're also cold, lumpy rocks hurtling through deep space with all the coordination of a dropped box of marbles. Their orbits, retrograde, eccentric, tilted. Basically everything your high school physics teacher warned you about when explaining stable motion. Some astronomers believe these moons were also captured objects, possibly once part of the Kuiper belt like Triton. But unlike her, they were never tamed. No slow circular compromise. These moons stayed weird. There's something oddly comforting about that. Take Halimede, for instance. She's a good candidate for having once been part of Nereid, the other major irregular moon, and perhaps was broken off in some ancient impact. She's also the least photogenic of the bunch, with a jagged, irregular shape and a surface that likely hasn't changed much since dinosaurs were having awkward first dates on Earth. And then there's Nereid herself. Nereid is kind of the awkward middle sibling in the Neptunian system. Not as close as the inner moons, not as far as Neso and friends. She was actually discovered back in 1949, long before Voyager 2 made its pass, and she's massive, by irregular moon standards anyway. Her orbit is one of the most eccentric of any moon in the solar system, swinging her from 1.3 million to over 9.6 million kilometers away from Neptune. That's like driving from one end of your town to the other, except instead of a traffic jam, you risk being slingshotted into interstellar space. And astronomers still argue whether Nereid used to be a regular moon that got jostled when Triton showed up, or whether she was always a bit of a loner with trust issues. Either way, her orbit is the kind of math problem that makes observatories wince. You pause here at the edges of Neptune's influence, letting the weak sunlight bathe the moons in pale gold. They drift like lazy thoughts, each carrying a tale you'll never quite understand. These irregular moons are hard to observe from Earth. They vanish into darkness for years at a time, their paths unpredictable, their shapes unresolvable even with our best telescopes. And that's part of their charm. They are the forgotten satellites, not grand enough to shape rings, not fast enough to spark curiosity, not close enough to threaten collision. They are the leftovers of the early solar system, relics of ancient chaos that settled into the loneliest orbits imaginable. You float near Psamatha now, so small, she's barely a whisper against the stars. Her orbit is so wide and slow that she might not have completed a single revolution since humans first invented the telescope. She doesn't seem to mind. These moons don't do much. They don't collide, don't shine, don't command attention, but they endure. And in a cosmos where survival is anything but guaranteed, that's its own quiet kind of magic. As you turn back toward Neptune's faint blue glow, one last thought lingers. These irregular moons are not beautiful in the way Triton is, or precise like Naiad and Thalassa, but they're honest, untouched, unchanged. You'll never know everything about them. No one will, and maybe that's okay. Now you glide inward again, back toward Neptune's tighter orbit, leaving the drifting outer moonfolk to their distant meanderings. It's like wandering out of a cold, silent field into the low hum of a party you forgot you RSVP'd to. And at this party, things are frankly still pretty weird. You're about to meet Proteus. Proteus is the second largest moon of Neptune and somehow still manages to be practically invisible to Earth-based telescopes. He's like that friend who's 6'4", but insists he's not into sports or attention. Just wants to read quietly in the corner. Thanks. Proteus wasn't discovered until 1989, when Voyager 2 finally cruised by Neptune and went, "Oh hey, there's a chunky lad hanging out here." It wasn't anyone's fault. Proteus is dark. Really dark. He reflects only about 10% of the light that hits him, which in cosmic terms is roughly the visibility of an old barbecue briquette floating in a lake of ink. But once you see him, you can't unsee him. He's big, just under 420 kilometers across, and roughly cube-shaped. Yes, cube. Most large moons get squished into spheres by their own gravity. But Proteus? He's just under the size threshold for that kind of makeover. So he floats around Neptune, shaped like a potato that gave up on being round halfway through. His surface is cratered and dusty, the complexion of someone who's been through a few too many asteroid breakups and hasn't exfoliated in 1 billion years. And sitting right there on his surface is a massive crater named Pharos, so large it nearly cracked Proteus open. If the impact had been a little stronger, you might be hearing this story from a completely different moon named Debris Cloud. Now, here's where it gets mildly suspicious. Proteus is unusually close to being disrupted, not just by impact, but by his orbit. He's situated uncomfortably near the Roche limit, the distance at which a moon would be torn apart by Neptune's gravity. If Proteus were much closer, he'd unravel into a glorious ribbon of space dust. Instead, he just sits there, quietly sulking at the edge of structural integrity. Astronomers still argue whether Proteus is a primordial object formed with Neptune, or if he's the survivor of some long-lost moon that was destroyed, possibly during Triton's dramatic arrival. After all, Triton's entry into Neptune's orbit would have been something like throwing a bowling ball into a lazy carousel of teacups. The resulting gravitational chaos could have obliterated earlier moons, and Proteus might be one of the few leftovers. He doesn't talk about it much. From a distance, Proteus seems still, stoic even, but you float closer and you notice something unnerving. Every part of him looks static. There are no signs of tectonics, no ice geysers, no faint atmosphere. It's like someone pressed pause on Proteus 1 billion years ago and forgot to hit play again. And yet, there's a certain nobility to it. Proteus is quiet, yes, but he's not passive. His mass is large enough to exert subtle effects on the other inner moons, tugging gently at their orbits over time, like an old librarian who doesn't speak often, but whose raised eyebrow can silence a room. And speaking of libraries, if moons had biographies, Proteus's would be titled Unappreciated and Underrated, because despite his size and interesting backstory, he's one of the least explored large moons in the solar system. Voyager 2 gave us a grainy portrait and then moved on. No follow-ups, no space missions, no Tumblr fan pages. You can almost hear him sigh, but don't let the stillness fool you. Proteus still holds secrets. His exact composition remains fuzzy. Is he mostly ice? Mostly rock? Some weird mix? No one's entirely sure. The darkness of his surface makes spectrographic analysis tricky, like trying to read a book with no light and a fog machine running. And there's one final curiosity. Despite being relatively large and orbiting close to Neptune, Proteus doesn't contribute much to Neptune's ring system, which is odd. Bodies that big and that close usually shed debris or get grazed by micrometeorites, supplying ring material. But Proteus seems unusually reserved. You float beside him now, close enough to make out the jagged lip of the Pharos crater. It rises before you like the scar of an ancient battle, whispering tales of whatever object slammed into Proteus with enough force to nearly end him. And still, he remains sullen, boxy, and enduring. You drift on, leaving him behind, and he fades back into the blackness as quickly as he arrived. No fanfare, no farewell. Proteus is many things, but above all, he is a survivor, a forgotten cornerstone in Neptune's dysfunctional moon family. Not rebellious like Triton, not distant like Neso, but solid, familiar, still holding his orbit, one quiet revolution at a time. As you leave behind the boxy silhouette of Proteus, your path brings you into the most intricate part of Neptune's moon system, the tightly packed, twitchy inner ring of satellites. This is where things stop being merely weird and start tipping gently into absurdity. You're drifting into the realm of Naiad and Thalassa. Now, remember how orderly moons are supposed to behave? Perfectly nested orbits, like Russian dolls in space? Yeah, forget that. Naiad and Thalassa are the moons that looked at Newton's laws, shrugged and said, okay, but what if... No? Let's start with Naiad. She's the innermost of Neptune's moons and an absolute tiny speck, barely 60 kilometers across. If she were on Earth, she'd be roughly the size of Rhode Island and probably just as full of potholes. And Thalassa? Slightly larger, but not by much. More like a sleepy provincial suburb of Naiad, orbiting just 2,000 kilometers farther out. What makes this pair truly bizarre isn't their size, it's their dance. Instead of orbiting neatly, one behind the other, Naiad and Thalassa move in a pattern so strange that astronomers didn't even know it existed until 2019. For decades, it looked like they should collide. They're only about 1,850 kilometers apart, a sneeze in astronomical terms, and yet they never crash. Why? Because Naiad is bobbing up and down, literally, while Thalassa sticks to Neptune's equatorial plane like a normal moon. Naiad zigzags over and under it in a perfectly timed orbital ballet. Every time Naiad passes Thalassa, she does so from above or below, like a cosmic ice skater ducking around her partner in a figure 8 routine that's been going on uninterrupted for possibly millions of years. Astronomers still argue whether this synchronized movement is a natural evolution or a leftover artifact from some ancient orbital chaos. It's like two subway trains on different levels, miraculously out of sync enough to never crash, no matter how many loops they run. It's not just beautiful, it's unsettling. No one really knows how such a precise pattern came to be. Was it luck? Some kind of tidal stabilization? Or is it just what happens when you cram too many moons into too tight a space and tell them to figure it out? You drift between them now, watching the celestial choreography unfold in silence. Naiad passes by with an almost sulky grace, her surface battered and dim, like a lost toy left too long in the attic. She completes an orbit in just over 7 Earth hours. A cosmic speed run, if there ever was one. Thalassa takes a little longer, plodding along like a sleepy librarian trailing a hyperactive child. But every 21 Earth days, Naiad laps Thalassa, and every time, she moves in that elegant undulation, never breaking formation. Of course, it helps that both moons are shaped like misshapen dinner rolls. They aren't spherical, not even close. They're long, lumpy, and probably riddled with cracks, craters, and past regrets. If you could walk on one, you'd be tripping over uneven terrain every few steps. Your lunar hiking boots would definitely get scuffed. As you follow them further, it's hard not to feel a bit hypnotized. The sheer stability of their mutual orbit defies logic, and yet it holds. In a solar system full of chaos and destruction, here are two little moons politely taking turns for eons. But things weren't always this peaceful. There's a strong suspicion among astronomers that this delicate choreography is the result of a massive reshuffling caused by Triton's arrival long ago. The capture of a large retrograde moon would have wreaked gravitational havoc on any existing system. So it's entirely possible Naiad and Thalassa weren't always dance partners. They might have been tossed into new orbits, forced into proximity, and eventually, somehow, settled into this improbable rhythm. Like two strangers stuck on a broken escalator who just decided to waltz. And just to keep things spicy, Neptune's ring system sits right below them, especially the faint Galley ring. It's possible the debris in those rings occasionally nudges their orbits ever so slightly, like a breeze moving the hands of a clock. But so far, no derailments. The show must go on. You wonder, as you drift between them, what's it like to be a moon whose entire existence is defined by the presence of another? Naiad doesn't just orbit Neptune, she orbits with respect to Thalassa. Her very survival depends on timing, tilt, and gravitational give and take. And Thalassa, she might never think about Naiad at all. She just plods forward, unaware she's part of a two-body act, the straight man in a cosmic comedy routine. You float above them both, catching one last glimpse of Naiad dipping gently below Neptune's equator again, like a sleepy bird folding into its glide. This isn't just orbital mechanics, it's choreographed resilience. And somehow, it helps you breathe a little easier. If these two tiny battered moons can figure out how not to crash, maybe there's hope for everything else too. Floating further away from the inner moon dance floor, you drift toward a different class of Neptune satellites, the irregular moons. These aren't the neat, obedient orbits of Proteus, or the quirky dance of Naiad and Thalassa. No, these moons are the misfits, the rebels, the celestial drifters who don't quite follow the rules. Think of them as the cosmic equivalent of that one uncle who always shows up to family gatherings late and tells stories nobody remembers. One such rebel is Halimede, an outer irregular moon with an orbit as eccentric as a poet's dream. Discovered only in 2002, Halimede is a small icy body, roughly 60 kilometers across, spinning around Neptune in a path tilted steeply relative to the planet's equator. If Neptune were a spinning top, Halimede would be the marble rolling randomly across the floor nearby. Unlike the orderly moons closer in, Halimede and her irregular cousins orbit Neptune on paths that are elongated, inclined, and sometimes even retrograde, meaning they orbit opposite the planet's rotation. You can imagine the chaos this creates. A moon travelling backward while Neptune spins forward. It's like trying to do a graceful waltz while one dancer insists on moonwalking. Halimede's origin story is a cosmic mystery. Astronomers still argue whether she was captured by Neptune's gravity after forming somewhere else in the solar system, or whether she is a fragment of a larger body shattered long ago. Interestingly, Halimede shares an unusual characteristic with another Neptune moon, Nereid. Both have similarly grey surfaces, suggesting a possible familial link, maybe siblings torn apart in an ancient collision. Speaking of Nereid, this moon is another story in Neptune's chaotic family. Unlike the neat orbits of the inner moons, Nereid's path is wildly elliptical, at times bringing it surprisingly close to Neptune, then swinging it out into the depths of space. It's one of the most eccentric orbits among moons in the solar system, leading to decades of astronomers scratching their heads. The elliptical nature of Nereid's orbit creates tidal stresses that make its surface a complex, ever-changing patchwork. But without a thick atmosphere or magnetic field, these changes are subtle and slow, perfect for a moon that's just trying to keep its balance without raising a fuss. Here's a quirky tidbit. Nereid is sometimes called the inconstant moon because its brightness varies dramatically, a trait not fully understood. Is it tumbling chaotically? Does it have weird surface features reflecting sunlight differently? Astronomers still debate. What's clear is that Nereid refuses to be boring, even if Neptune wishes she'd settle down. You find yourself imagining what a night might look like on Halimede or Nereid. No steady blue sky like Earth. Instead, you'd see Neptune looming large in the sky, a gas giant swirling with storms and clouds, reflecting a dim blue glow. Stars would shimmer faintly behind, unblinking and silent, as these moons slowly carry their secrets in orbits nobody quite dares to predict. The irregular moons remind you that not everything in space fits neatly into a grid. Some things are wild, unpredictable, and just a bit messy, like a toddler running loose in a library. But their eccentric orbits and unusual behaviours also tell a story of Neptune's violent past, of cosmic capture and collision, and the chaotic beauty of our solar system. You pause, letting the silence fill the space between you and these wandering moons, feeling the gentle pull of Neptune's gravity tethering this family of misfits. And as you drift away, you carry with you the reminder that sometimes being a little unruly is exactly what makes the universe interesting. You continue your slow journey outward, leaving behind Neptune's irregular moons and drifting into the shadowy realm of the planet's faint and ghostly rings. These aren't the glamorous icy rings of Saturn with their sparkling brilliance. Neptune's rings are subtle, dusty, and fragmented, a bit like the cosmic equivalent of a wispy scarf left in the wind. They're barely there, but they tell a surprisingly vivid story. The rings were first spotted in the 1980s from Earth-based telescopes, but it wasn't until Voyager 2's flyby in 1989 that we got a closer look. They're composed mainly of tiny dark particles, dust, ice, and whatever cosmic debris Neptune's moons have left behind over the millennia. Instead of bright ice crystals, Neptune's rings are coated in organic compounds, giving them a reddish hue that's almost like they've been stained by time. One of the most intriguing features in this dusty system is the so-called arc phenomena. These arcs are bright, dense clumps within the rings that stubbornly maintain their shape, refusing to spread out evenly as physics would normally demand. Imagine a group of friends in a crowded room who huddle together, refusing to mingle. It's a paradox that has puzzled astronomers ever since their discovery. The leading theory is that Neptune's tiny inner moons act as shepherds, gravitationally corralling the ring particles to keep these arcs intact. The moons Galatea and Larissa, for example, may play crucial roles in this delicate dance. Shepherd moons aren't unique to Neptune. Saturn and Uranus have them too, but Neptune's arcs seem particularly persistent and unusual, making them a case study in cosmic stubbornness. Another curious aspect is that these rings appear younger than Neptune itself, which is no surprise since rings tend to be transient features on cosmic timescales. They could be the remnants of a shattered moon or debris left over from cometary impacts. Astronomers still argue whether the rings will last millions more years or slowly fade into obscurity. As you drift closer, you notice the rings' uneven thickness and faint glow. They're mostly invisible to the naked eye, even from space, but their presence shapes Neptune's environment in subtle ways. For instance, the rings can act as barriers or traps for dust particles and micrometeorites, affecting how materials move around the planet. You might wonder how rings so faint can even be seen at all. Part of the answer lies in the way the light from the distant sun reflects off them at just the right angles. The rings are practically whispers of cosmic dust, catching the sunlight and scattering it like a faint glow of embers in a dying campfire. Among the arcs, one named Liberté stands out. Its name inspired by the French word for freedom, which feels ironic given how gravitational forces keep it confined. This delicate tension between freedom and constraint mirrors the restless nature of Neptune's moons themselves. From here, you gaze back at Neptune through the ring's faint haze, the planet's swirling storms casting shadows on the dusty veil. It's a serene scene, the quietest kind of cosmic poetry. These faint rings, often overlooked, are the silent witnesses to Neptune's history of moons misbehaving, colliding, and shaping the environment around them. As you float onward, you carry the faint dusty scent of space, if space had a scent, and marvel at how even the most subtle structures can hold stories of chaos, order, and the enduring pull of gravity. Your journey now carries you closer to the wild card of Neptune's family, Triton, the moon that just won't play by the rules. Triton is no ordinary moon. It's a behemoth among Neptune's satellites, a giant icy world that orbits in a direction opposite to Neptune's spin. That means Triton is a retrograde moon, a rare cosmic rebel whose very existence tells a story of capture and upheaval. Imagine Neptune spinning lazily on its axis, like a slow-moving carousel, while Triton speeds around it backwards, like a mischievous child running the wrong way on the merry-go-round. It's such an odd setup that astronomers have long agreed Triton didn't form alongside Neptune. Instead, it was likely captured, a wayward wanderer caught in Neptune's gravitational net. Triton's capture is believed to have been a violent event that reshaped the entire moon system. The gravitational chaos caused by dragging such a massive moon into orbit probably threw out or destroyed many of Neptune's original satellites, leaving only the irregular and inner moons you've already visited. It's like a cosmic game of musical chairs, where Triton arrived late and claimed the biggest seat. One of the most fascinating features of Triton is its incredibly smooth and young surface. When Voyager 2 flew past in 1989, it revealed terrain so fresh that it looked like the moon had just been dusted off. This is due to active cryovolcanism, geysers of nitrogen gas erupting from beneath the surface, reshaping the landscape and covering older craters with fresh frost. The geysers shoot nitrogen gas hundreds of meters into the thin atmosphere, creating surreal plumes that drift away in the thin, frigid air. You can almost hear the soft hiss of gas escaping, a quiet whisper on this distant icy world. But Triton isn't just a geological oddity, it's a thermal paradox. Despite being nearly 4 billion kilometers from the Sun, it has a surprisingly warm interior. Scientists debate whether tidal heating, caused by gravitational interaction with Neptune, or radioactive decay inside Triton, powers this internal warmth. It's one of those scientific mysteries that keeps astronomers busy over coffee. As you drift above Triton's surface, You notice the dark streaks of the plumes contrasting with the brilliant white of frozen nitrogen. The landscape looks like a frozen alien desert, sculpted by winds and eruptions. Interestingly, Triton's retrograde orbit is slowly causing it to spiral inward, inching closer to Neptune over millions of years. Eventually, it might reach the Roche limit, where tidal forces tear it apart, possibly creating a new ring system around Neptune. So, Triton's future is a slow-motion destruction that's part of the ever-changing story of this distant planet. You might find it oddly comforting to think that even the biggest and most rebellious moons aren't safe from the quiet, persistent tug of gravity's rules. As you pull away, you catch a final glimpse of Triton's icy plains shimmering softly under the distant sun, a giant moon whose very existence reminds us how dynamic and surprising the solar system really is. Drifting past Triton, your view softens to Neptune's hazy atmosphere, where the planet's iconic blue tones ripple with subtle storms and wisps of clouds. But tonight, your attention is drawn to a lesser-known atmospheric oddity, Neptune's great dark spot, a vast storm system that is both majestic and mysterious. Unlike Jupiter's great red spot, which has churned steadily for centuries, Neptune's great dark spot appeared suddenly and vanished just as mysteriously. Voyager 2 spotted it in 1989, a huge storm nearly the size of Earth, swirling at speeds over 2,000 kilometers per hour. Imagine the most intense hurricane you've heard of, but blown up to planetary scale and spinning in a deep blue gas giant atmosphere. What's fascinating is that subsequent observations with the Hubble Space Telescope found that this dark spot had disappeared within a few years, only for new dark spots to appear elsewhere on the planet. It's like Neptune is playing cosmic hide-and-seek with its own weather, shifting storms unpredictably across its surface. Scientists still argue whether these dark spots are holes in the methane clouds, deep vortices like cyclones, or complex atmospheric phenomena unique to Neptune's extreme conditions. The exact cause and lifespan of these storms remain an active area of research, adding to the allure of Neptune's dynamic personality. Beneath the violent storms and swirling clouds lies a planet with surprisingly layered atmospheric zones. Methane gas, responsible for Neptune's blue colour, absorbs red light, letting only blue wavelengths bounce back to your eyes. This gentle filter bathes the planet in its characteristic cool blue, soothing yet slightly alien. One quirky aspect: Neptune's winds are the fastest in the solar system, reaching supersonic speeds. Yet the planet's internal heat source, hotter than what it receives from the sun, fuels these storms. Astronomers still puzzle over how this internal heat is generated, whether from slow gravitational contraction, residual formation heat, or some other exotic process. Imagine standing on a distant spacecraft, watching Neptune's clouds swirl below, the great dark spot spinning silently but with immense power, a storm that eats energy yet disappears as quickly as it appears. It's a reminder that space weather can be as fleeting and unpredictable as weather back home. You feel a faint sense of calm in this chaotic atmosphere, a paradox of serene blues hiding fierce tempests, much like a calm ocean hiding the power of a storm beneath. Neptune's weather, like its moons, is a world of mystery, change, and endless fascination. As you move away, you carry with you the soft blue glow of a planet that's equal parts gentle and wild, a perfect lullaby for the cosmos. Your voyage gently leads you beyond Neptune's immediate reach, toward the distant outskirts of its gravitational influence, regions where its moons and rings fade into the cold, black depths of space. Here you consider Neptune's place in the grander celestial neighbourhood, specifically among the scattered disk and Kuiper belt, a realm populated by icy bodies and dwarf planets that hold secrets of the solar system's infancy. The Kuiper belt begins just beyond Neptune's orbit, a vast ring of leftover building blocks from the solar system's formation. These icy bodies, sometimes called trans-Neptunian objects, range from tiny chunks of ice to dwarf planets like Pluto and Eris. It's a quiet, distant frontier, but one that's intimately connected to Neptune's history. Interestingly, Neptune's gravity plays a shepherding role here too, shaping the orbits of many Kuiper belt objects, KBOs, through resonances, where an object's orbital period is a simple ratio of Neptune's own. Pluto, for example, is locked in a 3:2 resonance, orbiting the Sun twice for every 3 Neptune orbits, which keeps it safely away from Neptune's path, despite their crossing orbits. Astronomers still argue about how many of these KBOs were captured or nudged into their current orbits by Neptune's migration in the early solar system. There's debate whether Neptune moved outward from its original orbit, scattering and trapping these icy bodies in its wake. A cosmic dance that played out over millions of years. Beyond the Kuiper belt lies the even more remote scattered disk, home to bodies with highly eccentric and tilted orbits, probably tossed there by Neptune's gravitational kicks. These objects are the solar system's rebels, drifting on wild paths that sometimes take them closer to the sun and sometimes fling them deep into the void. Among these distant wanderers, you imagine the mysterious Planet 9, a hypothetical world some astronomers suggest lurks far beyond Neptune, influencing the orbits of scattered disk objects with its unseen gravity. While no direct observation has confirmed Planet 9's existence, the idea keeps minds curious and telescopes pointed outward. On a quieter note, many of these icy bodies show signs of primordial materials, compounds and ices that haven't changed much since the solar system's birth. Studying them is like opening a time capsule, offering clues about how planets formed and evolved. You picture drifting alongside one of these cold, distant rocks, sunlight a faint glimmer after a long journey. The silence here is absolute, broken only by the soft hiss of solar wind particles or the occasional cosmic ray. It's the edge of known space, where Neptune's reach blends into the vastness. The connection between Neptune and this distant realm reminds you that even the largest planets can influence the smallest fragments of our cosmic neighbourhood. It's a gentle tug across billions of kilometres, a silent partnership in shaping the solar system's structure. As you turn your gaze back toward Neptune, you feel a serene appreciation for the planet's role as both guardian and disruptor, quietly shaping the distant frontiers while hosting its own unruly moons and dusty rings. Your journey brings you back toward Neptune, this time focusing on the tiny, less celebrated moons tucked close to the planet. Those irregular satellites that seem to zigzag in every possible direction, as if Neptune's gravitational field is an invisible playground for cosmic misfits. Among these moons is Nereid, a moon that delights astronomers and casual stargazers alike with its wildly eccentric orbit. Unlike most moons, which follow neat circular paths, Nereid swings dramatically closer and farther from Neptune in an elongated ellipse that takes it on a bizarre cosmic roller coaster every few weeks. Nereid's orbit is so unusual that astronomers have spent decades puzzling over how it got that way. Some suggest it might have been knocked into its current orbit by Triton's violent capture or by gravitational interactions with other moons. Others think it might have been captured from the Kuiper belt and never quite settled down. The truth remains one of those scientific puzzles that tease astronomers late into the night. Despite its erratic path, Nereid is relatively small, just about 340 kilometers across, but it has a surprisingly reflective surface, coated with a mix of ice and rock. Its brightness varies as it tumbles through space, adding a subtle flicker to Neptune's entourage. Another intriguing oddball is Halimede, a small irregular moon with a chaotic orbit and a distinct reddish tint. Halimede is thought to be a fragment of another moon, possibly broken off by collisions long ago. Its colour and composition suggest a fascinating past, one marked by cosmic collisions and reshaping. Then there's Sao and Laomedea, two moons orbiting quietly, often overlooked, but contributing to Neptune's complex gravitational web. Each one adds a whisper to the story of Neptune's chaotic neighbourhood. Astronomers still debate whether these irregular moons formed alongside Neptune were captured from the Kuiper belt, or are the remnants of shattered larger bodies. The irregular moons are a menagerie of histories, telling tales of disruption, capture, and slow evolution in Neptune's sphere of influence. From afar, you imagine these small moons weaving through Neptune's magnetic environment, buffeted by solar wind and cosmic radiation. Their orbits cross and twist in unpredictable ways, a reminder that even in the cold vastness of space, nothing is ever truly still. As you reflect on these tiny wanderers, you realise how much of Neptune's story is written not just by the planet itself, but by its restless, misbehaving moons, each one a small actor in a grand cosmic play. And so you glide on, the tiny moons fading behind you, their paths traced in your memory like delicate threads of light in the dark. You now find yourself enveloped in the quiet mystery of Neptune's magnetic field, an invisible force that guards the planet and shapes its space environment. Unlike Earth's neat, dipole-shaped magnetic field, Neptune's magnetic field is oddly tilted by about 47 degrees and offset from its centre. This tilt creates a magnetic environment that's more chaotic and complex than many other planets. Voyager 2 revealed that Neptune's magnetic field doesn't just point neatly from pole to pole. Instead, it's lopsided and wobbly, creating strange auroras and interactions with charged particles. Imagine a spinning top that's wobbling wildly while glowing faintly in the dark. This is the nature of Neptune's magnetic field. One reason for this unusual field might be Neptune's interior structure. The planet's magnetic field is thought to be generated in a relatively shallow shell of electrically conductive fluid, possibly a slushy mixture of water, ammonia, and methane under extreme pressure. This differs from Earth's magnetic field. generated deeper within its molten iron core. The tilt and offset create regions where the magnetic field lines open up in unexpected ways, letting solar wind particles funnel into the atmosphere and create auroras, though much dimmer and harder to detect than Earth's northern lights. Astronomers still argue about how much the magnetic field changes over time and what that means for Neptune's atmosphere and radiation belts. Neptune's magnetic environment also affects its moons. Charged particles trapped in the magnetic field bombard moons like Triton, slowly altering their surfaces and atmospheres. This subtle weathering is part of the moon's ongoing stories, even if it's invisible to human eyes. Interestingly, the magnetic field's complexity means that spacecraft approaching Neptune have to navigate a tricky environment, full of unexpected radiation zones and shifting field lines. It's like a cosmic obstacle course, where invisible forces play catch and release with charged particles. You float in this invisible dance, feeling the quiet power of forces you cannot see, shaping everything from auroral glows to the charged particle environment around Neptune. As you pull back from Neptune's magnetic cocoon, you carry a deeper understanding of how this distant giant is more than a planet. It's a dynamic system, alive with unseen currents and subtle forces. The magnetic field, like the planet's misbehaving moons and shifting rings, is a reminder that Neptune's story is one of complexity and quiet wonder. As you gently retreat from Neptune's magnetic field, your mind lingers on the planet's subtle beauty and the oddly charming chaos of its system. The interplay between Neptune's shifting rings, misbehaving moons, and turbulent atmosphere paints a picture of a world that defies the neat order we often expect from our solar system's giants. You recall how the planet's tilt and retrograde moon Triton hint at violent histories, while the faint rings whisper tales of cosmic dust and forgotten collisions. The scattered irregular moons, with their eccentric orbits, feel like an ensemble cast of misfits, each adding their unique rhythm to Neptune's cosmic symphony. Amid all this, Neptune's own internal heat and swift winds remind you that this distant world is anything but dormant. It breathes and shifts in ways that challenge your assumptions, inviting endless curiosity and quiet reflection. Astronomers still debate many of Neptune's mysteries: the origin of its internal heat, the fate of its spiraling moons, and the secrets hidden beneath icy surfaces. But tonight, as you drift in the serene cosmic quiet, those questions settle softly in the background, like gentle echoes that will keep whispering long after you've moved on. Neptune's story, with all its twists and quirks, is a lullaby of slow change, a reminder that even the most distant and mysterious worlds are dynamic and alive in their own way. Now, as your journey through Neptune's realm comes to a close, you can feel the comforting hum of space's vast calm settling around you. There's no rush here, only the endless, gentle unfolding of celestial time, the slow dance of moons and rings, and the faint blue glow of a distant giant watching over its small, chaotic family. Rest now, knowing that the cosmos carries on, quietly and beautifully, far beyond the reach of any hurried thought.